All right, so we dealt with rational square roots. Rational square roots, a group of rational square roots. Some of them are perfect squares. Perfect squares produce rational square roots. So the square root of 36 equals 6. The square root of 49 equals 7. Remember, why are they considered perfect squares? Well, when we saw the square root of 36, we knew that we could write it as 6 squared, right? 6 times 6 equals 36, so we could write that as 6 squared. The square root and the square cancel each other. They are inverses, and it leaves you just with 6. So that's our whole objective here, is always to look for perfect squares. So yesterday was rational square roots. Today we're going to deal with irrational square root, irrational radicals. Oh, hello. So if we look at this, we do the square root of 36 on our calculator. 36 square root equals 6. It gives us a rational number. What if we have the square root of 8? So if we do that on our calculator, 8 square root, we get 2.828427124744619, and the numbers continue. Just because the calculator doesn't show it doesn't mean that it stops at 9. It keeps going on forever. So it is non-terminating. A number that does not end is called non-terminating. And we notice that there is no pattern with those numbers, and so they do not repeat. It's called non-repeating. So an irrational number is a number that does not repeat and does not end. Non-terminating, non-repeating. However, we can still simplify this radical. So when we want to simplify, we got to simplify this. So we want to break this up. Can we break this radical up into factors of 8? So when we talk about factors, those are numbers that multiply or divisible. Factors of 8. So factors of 8 are 1 and 8. 2 and 4. So they produce 1 times 8 equals 8, 2 times 4 equals 8. So can we find factors that we might be able to simplify? Well, yes. We like this. This has a perfect square in it. 4 is a perfect square. So if I break this into square root of 4 times 2, and then remember in yesterday's lesson, I told you when radicals are being multiplied, we can separate them into their own house. And then we notice that the square root of 4 can be simplified because it's a perfect square. So that would become 2 rad 2. So square root of 8 can be simplified to 2 rad 2. So it will be important that when we get numbers that are not perfect squares, like the square root of 8, that we make sure that they are simplified. So if we had the square root of 100, that would be a perfect square. If we have the square root of 20, maybe that is not a perfect square. So we have to look and see, are any of the factors of 20 a perfect square? 1 times 20, 2 times 10, 3 no, 4 times 5. So of these factor pairs, are any of those a perfect square? Yes. 4 is a perfect square. We wouldn't choose 2 and 10. We wouldn't choose to break it up into rad 2, rad 10, because neither are perfect squares. So we wouldn't be able to simplify that. However, if we look at 4 and 5, that does help us. That would be beneficial because if we break it into square root of 20, we could break it into the square root of 4 times the square root of 5. And we chose 4 and 5 because 4 is a perfect square and we can simplify it. That turns to 2 rad 5. So I have simplified this radical. Square root of 20 can be simplified to 2 times rad 5. What if I get a number big like 200? Now we could go through the factors of 200. Factors of 200 are 1 and 200, 2 and 100, 3, no, 4 and 8, 4 and 80, no, hello Mr. Mac, 4 and 50, ooh, that was bad, 5 and 46, does 6 go into it? Nope. 7, no, 8, yes. 8 and 25, 9, no, 10 and 20, 11, 12, no, 13, 14, I think that's it. Yeah, yep, those are the factors. Now, that takes some time. We can make that more efficient because what numbers really help us out? What numbers have helped us out when we broke them into, what numbers have helped us? Perfect squares. So when we look at factors, we're just looking for perfect square factors. So instead of breaking them down like that, I would just look and say, hey, we can start off with square root of 1, square root of 4, square root of 9, square root of 16, square root of 25, square root of 36, square root of 49, square root of 64, square root of 81, square root of 100, square root of 121, square root of 144. And they keep going on. And if any of these numbers, 4, and we wouldn't do 1, because square root of 1 is 1 and it just produces our same number. So we really wouldn't be concerned about 1 as a factor. What we want to look is, are any of these, we're always looking to find factors of the number we're dealing with that are perfect squares. Well, those perfect squares are 4, 9, 16, 25, 36. So when we look at 200, we're really looking at, does 4 go into 200? Does 9 go into 200? Does 16 go into 200? Does 25 go into 200? Does 36, etc., 49, 64, 81, 100? So we want to find factors that are perfect squares. So we see that 4 is a perfect square, 25 is a perfect square, 100 is a perfect square. So notice if we go through, we're looking for those pairs. So one way that we could do this is we could break this into rad 4, rad 50. And we chose 4 and 50 because 4 is a perfect square. So square root of 4 is 2 rad 50. And what we have to be careful about is we have to make sure that we have simplified it completely. Is this simplified? Well, we go through the question again. We still have a radical here. So we have to say, hey, sorry, wrong direction. Does 4 go into 50? Does 9 go into 50? Does 16 go into 50? Does 25 go into 50? So I may need to still break 50 up. And in this case, we do. So 50 can be broken into rad 25, rad 2. And why did I choose 25? Because it's a perfect square. So we're constantly looking for factors that are perfect squares. So that becomes 2. Square root of 25 is 5. Rad 2. 2 times 5 is 10. Rad 2. And now we're done. So we've simplified the square root of 200. Oh, sorry. Yes, I could have, sorry, I broke it into 4 and 50. I could have broken into 25 and 8, which would have given me rad 5, rad 8. And rad 8 would be rad 4, rad 2. And 5 times 2, rad 2. And notice we end up with 10 rad 2. So it doesn't matter which set or which number you look to group it with, which perfect square you look to divide it by. We could have also have done rad 100 times rad 2. And that would have given us 10 rad 2. And that would have been the most efficient way. So it doesn't matter which group of factors you pick, just as long as one of those is a perfect square. We wouldn't choose 5 and 40 because 5 is not a perfect square and 40 is not a perfect square. We wouldn't choose 10 and 20. Neither is a perfect square. We only want ones that can come out of the house, per se. All right, let's try a couple. So rad 32. So I'm going to start with 4. Does 4 go into 32? Yeah, 4 times 8. So rad 4 times rad 8 gives me rad 32. Rad 4 simplifies to 2. Now I have to check and make sure, is 8 simplified? So I'm going to start with 4. Does 4 go into 8? Yes, it does. Rad 4, rad 2. So it becomes 2 times rad 2. Now these 2's are outside, so I can simplify them because they're both on the outside. So 2 times 2 is 4. So my answer is 4 rad 2. 96. Square root of 96. I'm going to start with 4. Does 4 go into 96 divided by 4? Yes, it does. 24. So rad 4, rad 24. That becomes 2 rad 24. Does 4 go into 24? Yes, it does. Rad 4, rad 6. 2 times rad 6. We get 4 rad 6. Does 4 go into 6? No. What's my next perfect square after 4? 9. Well, 9's bigger than 6, so we don't do it. So this is simplified. Rad 6 is simplified. Let's try 216. No, let's not try 216. Let's try 54. Does 4 go into 54? No. What's my next perfect square? 9. Does 9 go into 54? Yes. Rad 9, rad 6. That becomes 3 rad 6, and as we already know, rad 6 is simplified. 150. Does 4 go into 150? Nope. Does 9 go into 150? Nope. Does 16 go into 150? Nope. Does 25 go into 150? Yes. So there's my rad 25, rad 6. That becomes 5 rad 6. So you see, each time I look for 4, 9, 16, 25, 36, 49, blah, blah, blah. So you always try, those are the factors. Ooh, I like this one. So you have negative 5 rad 80. So remember, when we see 5x, that really means 5 times x. When we see 5 rad 2, that really means 5 times rad 2. So when we see negative 5 rad 80, that just means negative 5 times rad 80. So let's see, does 4 go into 80? Yes, it does. Rad 4, rad 20. So negative 5 is on the outside. Square root of 4 becomes 2. Now 2 is on the outside. 20. So that gives me negative 10 rad 20. I have to make sure that there's no perfect square factors of 20. Does 4 go into 20? Yes. So I get negative 10 times 2 is negative 20 rad 5. And that would be my simplified answer. So the nice thing here is, it's a good activity, and you might want to try this, is find the square roots. I want you to simplify the square roots from 1 to 40. So the square root of 1, the square root of 2, square root of 3, I want you to do each one of those all the way up to the square root of 40. So pause the video. Should take you maybe about, I don't know, 4 minutes, maybe 5 minutes max. Try that, and when you're ready, hit play and we'll go through it. All right, square root of 1 is 1. Square root of 2 cannot be simplified. Square root of 3 cannot be simplified. Square root of 4 is 2. Square root of 5 cannot be simplified. It does not have any perfect square factors. Square root of 6 cannot. Square root of 7 cannot. Square root of 8. Square root of 8 can be broken down to rad 4, rad 2, and then you get 2 rad 2. Square root of 9 is 3. Square root of 10 cannot be simplified. Square root of 11 cannot be simplified. Square root of 12 we can break into rad 4, rad 3. So it becomes 2 rad 3. Square root of 13 is the square root of 13. You'll notice that any prime number will not be able to be simplified outside of 1. 1 is actually 1 is not even prime, sorry. 2 is the first prime number. 2, 3, 5, 7, 11, 13, 15, 17, 19, 23, 20, nope, that one's good. So any prime number is going to stay as a radical, cannot be simplified. Square root of 14 is okay. Square root of 15 stays as rad 15. Rad 16 equals 4. Rad 17 cannot be simplified. Rad 18 can be broken into rad 9, rad 2. Rad 9 becomes 3, rad 2. Rad 19 is prime. Rad 20, rad 4, rad 5, so it becomes 2 rad 5. Rad 21 does not have a perfect square factor. Square root of 22. Square root of 23 doesn't. Square root of 24 is rad 4, rad 6, so 2 rad 6. Rad 25 is 5. Rad 26 cannot. Rad 27 is rad 9 times rad 3. Rad 9 becomes 3 rad 3. I love this one. Rad 28 can be simplified. Rad 4 times rad 7, so it's 2 rad 7. Rad 29 cannot be simplified. Rad 30 cannot be simplified. Rad 31 is prime. Rad 32 is not only 4 and rad 8, but let's get bigger, 16 and 2. So rad 16 times rad 2 becomes 4 rad 2. Rad 33, rad 34, rad 35, rad 36 is 6. Rad 37 is prime. Rad 38 has no prime factors. Rad 39 has no prime factors. And rad 40 is 4 times 10. Rad 4 times rad 10, so that's 2 rad 10. Cool. That's a pretty good activity to help you brush up on your radicals. I think that's pretty much it. I don't think that there's, yeah, we've done that. That's a good one. Yeah, we can do this one. So this is -1 times rad 50. -1, we're going to break rad 50 into rad 25, rad 2. So -1 times 5 times rad 2. So you get -5 rad 2. All right, come and see me if you have questions.